Hello, in this video I will explain the MATLAB environment and walk through some of the commands, operators, and functions, or how MATLAB work briefly to help you with the exercises of labs 1 and 2. First, let's introduce the environment of MATLAB, starting from the command window. Command window is the area where we can type commands in MATLAB and get the response from MATLAB. On the left side here, you see the current folder. And here you will be seeing or looking at all the MATLAB files that are saved within the working directory. To find out the working directory, you can simply look at the URL in here. By default, you'll be working in the MATLAB folder. Here I have created a folder named lab, and in the folder lab I have a file saved already that is named filename.m. .m is again the extension of a MATLAB script file. In here, this is called the workspace. You will see all the variables that are saved in your code. Alright, so let's start by introducing or experimenting with MATLAB as a calculator. For example, if I want to find 2 plus 8, I know the answer should be 10. If I hit enter, MATLAB is going to say the answer is 10. So this is actually accurate. Let's try, for example, calculating 3 times 10. The answer is 30. Now I've used MATLAB to calculate addition, multiplication. Similarly, you can use it to divide. Alright. For the power operation, we will have to use the hat. For example, 2 raised to the power 4. That's how you type it in MATLAB, and the answer you get is 16. We can use multiple operators together in one command and store the results in a variable, say named a. So we can say a is equal to 4 plus 2 raised to the power 2. Before I hit enter, I want to highlight that in the workspace I have a variable named answer, and that variable is a built-in variable in which you will see the value of the latest computation. In this case, it's 16 from the previous computation. 2 raised to the power 4 is 16, and the answer was saved in the variable answer because I didn't name it, or I didn't put the value in a variable. I didn't store it somewhere. The last command I'm typing is a is equal to 4 plus 2 raised to the power 2, meaning I want to calculate this and store the result in a variable named a. So this will create a new variable in the workspace called a, and its value is equal to 8, as you can see here. Okay. If you want to impose the priority order, you can use brackets, just like with any calculator. For example, you can say C is equal to, I want to add 2 plus 4 first, and then multiply the result by, say, 5. You can hit enter, and that's the result. Similarly, you can perform operations on variables. For example, I can add a to c by saying a plus c, and then hit enter. So what we did now is we added the value of a to the value of c. I didn't store the results in any variable, so MATLAB put the results in the built-in variable answer. Alright. Sometimes you want to perform operation or calculate values and just store them in a variable without displaying them in the command window. In this case, what you can use is the semicolon. The semicolon in MATLAB is used to suppress the answer, or to suppress the output from the command window. For example, I can type 2 times a semicolon, but let me store it somewhere. I can call it new a, for example. New a is equal to 2 times a semicolon. Now this will create a new variable named new a, in which I will store 2 times a, which is 16. Hit enter, you will see that now a new variable has been created and its value is equal to 16. Alright. So far, all my variables that I've created are scalar variables, meaning just one singular number. In MATLAB, you can also create vectors, which are basically arrays in other languages. Vectors can be row vectors or column vectors, meaning one single row with different columns, one or more columns, or one column with multiple rows. By default, vectors in MATLAB are row vectors. So to create a vector, you'll have to use the square bracket. This is how to open the bracket or open the array. That's how you close it. I'm gonna put a semicolon because I don't want to display the results, and I will store the values in the array named v. So the elements in v, I want them to be 2 and 4. You can use a comma, 2 and 4, to separate elements in an array, or you can use a space. Both will work. You can use both in the same at the same time if you want. For example, 2, 4, space 6. All right. Now v has 3 elements, 2, 4, and 6, as you can see here. Okay. I'm gonna create a new vector. I will name it r. R has 1, 5, and 10. This time I used spaces to separate elements in the array r. Now I'm gonna hit enter. This creates a row vector named r whose elements are 1, 5, and 10. I can type r and hit enter to look at the values of r, or I can look at them from here. All right. If you want to figure out how many elements a vector has, you can call the built-in function length. So length, all lowercase, open bracket, and type the vector, the variable name, for example, v. This will output the number of elements in vector v. In this case, it's 3. 1, 2, 3. So it will say 3. You can perform operations on vectors. For example, you can say minus v. This will negate the elements in v. It's not going to change v, but rather compute minus v, which will simply multiply each element in v with minus 1. Look, observe that v hasn't changed. Only the variable answer has changed to minus v, which is simply negative 1 multiplied by vector v. If you want, you can save this in a variable. You can name it new v. Let me put it this way. So v is actually 246. New v, if you want to look at it, is minus 2, minus 4, minus 6. Okay, let's, for example, add v to a new v. What this will do is add each element in v with its corresponding element in new v. So it will be 2 plus minus 2, 4 plus minus 4, 6 plus minus 6, which will simply give me an array of all zeros, 0, 0, and 0. Notice that the sizes of v and new v are equal, which is why adding them together was possible. So be careful when performing operations between vectors. Pay attention to the sizes or the lengths of vectors. For example, if I attempt to add this vector to, say, this vector, MATLAB will give me an error because the first vector has 2 elements, the second vector has 3 elements, so adding them is not allowed. The error says matrix dimensions must agree, meaning this is a 1 by 2 matrix, this is a 1 by 3 matrix, meaning the sizes do not agree, so adding them is not possible. Okay, let's look at array R again. So this is R. If I want to find the reciprocates of each element in R, since I said each element, that means I want to perform element-wise operation on R. So for this, I will have to do dot divided by. So instead of using the division operator, I will use the element-wise division, which is dot divided by, or dot then slash. I want to find 1 dot divided by R. This will give me the reciprocate of each element in R. So 1 over 1 is 1, 1 over 5 is 0.2, 1 over 10 is 0.1. What if I want to find, or if I want to raise each element in R to power 2? Again, I said each element, so I'll have to perform element-wise operation. Again, this is R. Let me store it in a new variable. I'll call it R2. In R2, I want to find R dot power 2. So raise each element in R to power 2. I'm going to put semicolon because I will simply store the results in R2. I don't want to display them. So look at R2 here. Observe that R2 is simply 1/2500 because R is 1, 5, 10. So if I raise each element in R to power 2, this is what I will get. 1 raised to the power 1 is 1. 1 raised to the power 2 is 1. 5 raised to the power 2 is, let's look at R2 here. I'm gonna type CLC. This is something else that you can type in the command window, which will clear the command window. It's not gonna delete anything in the workspace. It will simply clear all the commands. So I'm gonna look at R and R2. Remember, R2 was actually, as a comment, I'm gonna say it's R raised to the power 2. R is 1, 5, 10. R2 is 1 raised to the power 2 is 1. 5 raised to the power 2 is 25. 10 raised to the power 2 is 100. All right. Now, if I want to perform element-wise multiplication between two arrays, let's say, let me create them and name them T1. T1 is 2, 3, 4. T2, say, is 4, 2, and 5. If I perform element-wise multiplication between T1 and T2, what this will give me is the result of multiplying each element in T1 with its corresponding element in T2. So 2 times 4, 3 times 2, 4 times 5. The results are 2 times 4 is 8, 3 times 2 is 6, 4 times 5 is 20. The reason why this works is because T1 and T2 are of the same size. They're both of length 3, or this is a 1 by 3 matrix, 1 by 3 matrix. They both have the same size, and I used element-wise multiplication, dot multiply. All right. When we use multiplication on scalars like 2 times 4, we do not need to put the dot. Here we did need it because these are vectors and we're aiming to perform the operation on the elements of these vectors. So this is an element-wise operation. I'm not doing matrix multiplication here. I'm simply multiplying the elements in T1 with the corresponding elements in T2. So the dot here is necessary. Okay, let's move on to colon notation in MATLAB. This is the colon. It has multiple uses. First one is as a shortcut to create arrays in MATLAB. So I'm going to create a new array named A. I know I already have A, but Doing this will overwrite the variable a. So it will delete a and put this new value for a instead. So my array is going to be from 1 until 10. So I use the colon notation to help me save time instead of listing 1, 2, 3 until 10. Alright, so if I look at a, it's now an array starting at 1, ending at 10 with an increment of 1. So I'll say, I'm gonna just say as a comment, start at 1, increment by 1 until you, or let's say the limit is 10. Limit is 10. Do not exceed 10, simply. If I want to do the same thing but have an increment value different from the default one, I'll have to use 2 colons. So let's say k is equal to, I want to start at 4, increment by 0.5, for example, until I reach 7. So this will mean, as a comment, I'm going to put the comment sign, which is the percentage. Notice how the text is changed to green. This means this part of the code is not compilable. It's just a comment for me to understand what I'm doing. So I'm going to say start at 4 actually. This is the starting value. The increment value is what's between the 2 colons. If there is 1 colon, then the increment value is 1. Start at 4, increment by 0.5, and the limit is 7, meaning you should not exceed 7. This is key. It will be 4, 4.5, 5, 5.5, 6, 6.5 until 7. Okay. Another way to use the colon notation is when extracting elements from a vector. Let's look at, for example, vector A. This is vector A. It's stored here. If I type A1, this will extract the first element in A. So it will give me number 1. Okay. If I type A and, this will give me the last element in A. In this case, it is 10. Okay. Let's see what is the element before the last one in A. So not the last element, but the one right before it. This should give me 9 because that's the element before the last one. Okay. I'll repeat this but on a different variable. So this is k. Let me expand this window so k will be displayed in one single line. This is k. K2 will give me the second element in k. It will extract the second element from k, the element lying at index 2 in k, which is 4.5. Remember that indices in MATLAB start at 1. So k1 is the first element in k. Now, if I want the first 2 elements in k, I will use the colon notation starting at 1, ending at 2. So this will give me elements from the first until the second. It will give me 4 and 4.5. If I do like k 2 until 4, this will give me the elements at index 2, index 3, index 4. So it will give me the elements from 4.5 until 5.5. Alright. Similarly, I can find the last 2 elements or the last 3 elements in any array. I'm going to use k as an example by calling end minus, and then it depends on how many number of elements I want to see, until end. So this will give me the range of end minus 2 until end. In this case, it will display the last 3 elements in k. If I want the last 2 elements, I'm going to say end minus 1 until end, and so on. So far we looked at row vectors, and we said vectors in MATLAB are row vectors by default. So I simply created them using the brackets like this or the colon notation. So if I say 1 until 4, this is a row vector. To convert a row vector to a column vector, you can simply use the colon notation. So let's do R transpose. You'll use the transpose, operator. So the transpose operator is simply the apostrophe. So R transpose will convert R from a row vector to a column vector. It's not going to change R, but it will simply display. If I want to change R intentionally, if I want to overwrite R, I will simply do this instead. So now R will be R transpose. So this is the new R. Okay. If I want to change it back to its original size, I'm going to do this. Okay. I can also create a new variable named D, for example, whose elements are going to be, say, 3, 4, 5, transpose, like this. Now, D is going to have a size of 3 by 1, 3 rows and 1 column, as such. So it is currently a column vector instead. Okay, this is it for the column notation. Now, the last thing we will introduce is, this is it for the transpose, So the last thing we want to introduce today before the help command is how to plot in MATLAB. In MATLAB, you can plot using a command called plot. But before we call it, we'll have to have two arrays, the independent array and the dependent array. I will create an array named x, for example, whose elements are 1 until 20. So x is going to be 1, 2, 3 until 20. Y is my dependent variable. It depends on x. I will, for example, say 2 times x plus 1. This is my y. Now I can call plot. Make sure to put the x-axis first, or the independent axis, because x doesn't depend on anything. And then y, since y depends on x. So y is going to be my y-axis. If I hit enter, I will see the figure window with the plot of y of x. But notice how there's no title and the axes are not labeled. So to fix that, I'm going to say x label, all one word. Make sure you spell label properly, and in quotation marks you can use double quotation or single, either way is fine. X label x, y label is y of x, and the title is plot, for example, of y of x is equal to 2x plus 1. Remember to close the bracket. So this is how you look at the figure. This is how you plot and add labels to your plot. Okay. That's the x label, the y label, and the title. You can also add a grid if you wish by typing simply grid. The figure window can be in the background sometimes. So this is the grid lines these are the grid lines that we added. I'm going to clear the command window by typing CLC and highlight that if you need help from MATLAB explaining how to use a command or how to use an operator, you can call the command help followed by the function, for example, sine. That's how you can call the sine function. Okay, it shows you how to use it and what it does. For example, you can use help plot. It will indicate to you how to use plot and what it does, etc. So remember, if you need help with MATLAB, simply use the command help. Read the results to understand how things work, how commands work, or built-in functions.